Today, we're breaking down the basic anatomy of a strain gauge load cell using this internal cutaway view. Understanding what's inside a load cell, and why each component matters, helps explain how accurate force measurement is achieved in real-world applications. High-quality threads. Starting at the top, you'll see the high-quality threads. These threads are machined with tight tolerances and precise perpendicularity, ensuring proper alignment when the load cell is mounted. Accurate threading is critical because even small alignment errors can introduce measurement inaccuracies. Accurate machined base. At the bottom is the accurately machined base. This surface is flat and smooth to provide excellent mounting contact. A stable mounting surface ensures the applied force transfers cleanly into the sensing element, improving repeatability and accuracy. In-house CNC machining. The internal body of the load cell is precision machined using in-house CNC processes. This level of control allows for consistent geometry, tight tolerances, and reliable performance across production units. Moment compensation during production. The internal structure is designed to reduce the effects of off-axis loading. This moment compensation helps minimize errors caused by side loads or bending moments, which are common in real-world applications. True fatigue specification. Load cells experience repeated loading over time, which is why fatigue performance matters. This design supports fully reversed cycles through zero at full capacity, ensuring durability and long-term reliability in dynamic applications. Proprietary high-output strain gauges. Inside the load cell, proprietary high-output strain gauges are carefully bonded to the sensing element. These gauges are matched to the flexure for optimal performance and arranged in a full bridge configuration, allowing the load cell to convert mechanical strain into an electrical signal with high sensitivity. Temperature compensated strain gauges. Temperature changes can affect strain gauge readings, but temperature-compensated gauges help eliminate signal loss caused by expansion or contraction. This allows the load cell to maintain accuracy across a wide range of operating conditions. Class-leading performance. All of these features work together to deliver class-leading performance. The result is a polished accuracy specification with minimal variation from unit to unit and consistent performance you can rely on. This cutaway view shows that a load cell isn't just a solid block of metal, it's a carefully engineered system where machining, strain gauges, temperature compensation, and mounting design all play a critical role in accurate force measurement.